Good morning everyone. This is Sanyam Kumar and today I am going to explain you all a topic of mathematics and that is arithmetic progression. So let's start. Arithmetic progression. If we see the word arithmetic progression, we get one thing, that is first of all progression. Progression means moving towards something and arithmetic in a systematic way. First of all, let us understand the difference between a sequence and arithmetic progression. So if I write a sequence 1, 3, 9, 12, 100. This is a sequence. As some number are going and between them the comma is there, means a sequence is written. But if I write a progression, that is 1, 2, 3, 4, 5. Here we can see one thing, that there is a system in which the progression is going, and the system is that the difference of the second term and the first term is 1. So here we can see a system is going on, and when a progression go in a systematic way, we say it arithmetic progression. Now before understanding the chapter more clearly, first we would see some terms. So in arithmetic progression, we name some terms as first A, that is the first term. Now L, that is the last term. AN, it is the nth term. AN and L is almost same but not exactly same. We will see the difference further. Now next, that is N, number of term, and T, common difference. First term. What can be the first term? Suppose I write a sequence 1, 2, 3, 4, 5. Here we can see 5 terms are there, in which the first term from where the progression is starting is known as the first term, that is A. Now L term means the last term. So 5 is the last term of this particular progression, so we will name it as N. Now nth term. I said you I will talk about the difference between L and nth term. So nth term is the last, L term is the last term, whereas nth term is also the last term, but when we exceed this term till the infinity, then the number at the infinity will be the nth term. But if we I would particularly say the last term, if I say 5 is the last term, then the 5 will be the last term, but nth term is till the infinity. Now N, number of term. In this particular progression we can see there are 5 numbers, so N will be 5. And at the last T is the common difference. And how do we calculate common difference? We all know, that is second term minus first term. So 2 minus 1, 1. So in this 3 minus 2, 1. So in this whole progression the common difference is 1. Now if we move ahead for writing and progression, we'll go like first write an equation, progression 1, 3, 5, 7, 9, 11, so on. So here we can see a progression in which there are 6. In this there are 6 terms. First we see if the first term we already know is known as the A, and if we want to write the second term, I told you already one thing, that is T. T is the common.
Good morning everyone. My name is Rehma Farhan and I am from class 10A, GD Goenka Public School, Gaya. Today I am going to prove BPT or the Thales theorem. This theorem states that in a triangle, if a line divides two sides in the same ratio, then this line is parallel to the third side, which means that if BE divides AB and AC in the same ratio, then BE is parallel to given, we have to prove that AD by DB is equal to AE by EC. So we will draw EN and DN as the respective heights of this triangle. We will take DE as the base. We will take AE and AD as the base, DN and EN the heights of this triangle. From that we will get area of AD, which is half into BN into AD. Now this triangle can be taken with two different pairs of height and side. So we will get one more area, that is half into EN into AD. Now in this portion we have two triangles, BDE and BEC. If B is parallel to BC and both of these triangles lie on the same base, then BDE and EBC have equal areas. So from that, area of triangle BDE is half into BD into BA and area of triangle BEC is half into EC into EF. This must be equal because triangles on the same base lying under same parallel have equal areas. We have got this fifth equation. Now we will divide this fifth equation with areas of AD. We will use different areas to match the sides. We will get half into DD into AN upon half into DN into AD equals half into EC into EN upon half into EN into AD. After eliminating everything, we will get DD upon AE equals DD upon AE. We can also reciprocal this to get this result, which is AD by DB into AE by EC. We have proved that DE divides AB and AC in the same ratio.
Good morning everyone. I am Ayush Ranjan from GD Goenka Public School, Gaya, Bihar, and I am a student of grade 10. Today I am here to explain basic proportionality theorem. Let us start. First we have to know the basics of this theorem. This theorem is also known as the Thales theorem. So if we have this triangle states that this theorem states that if we have a triangle ABC and there is a point D on the side AB and there is a point E on the side AC such that DE is parallel to BC, it is true that the ratio of AD to DB is equal to the ratio of AE to EC. And today we are going to prove this theorem and this relation without using the concepts of congruency. First, we have given that DE is parallel to BC and we have to prove that AD by DB is equal to AE by EC. First, if we see this figure, DECB, it is a trapezium, and if we draw the diagonals of this trapezium, we get many triangles. Now we need to do a construction. We need to draw a perpendicular line from D on the side AE. This line will meet AE on the point N, and the perpendicular line would be DN. Similarly, the perpendicular line on AD would be EM. Let us start proving this theorem. To prove this theorem, we have to make such equations such that we can equate AD and DB to AE and EC. We can prove this by the area of triangles. We know that the area of triangles is half into base into height. I see if I take the triangle ADE, I can make two equations in which I can have AD, AE, NE and DN. And if I make equations for triangle DBE, I will also, in this equation, I will have DB and EM. And for the equation of area of triangle EDC, I will have EC and DN. And later I can equate these to get the relation between ADDB and AEEC. So with this mindset, let us start to prove this theorem. First we will write area of triangle ADE. First let us consider the side AE as the base of this triangle. So half into base, which is AE. and the perpendicular to this side is DN. Another equation for the area of triangle ADE would be half into AD. This time we are considering AD as the base. So the corresponding perpendicular would be EM. This is equation 1 and this is equation 2. So let us equate 1 and 2. Why? Because both the LHS are the same. So we are equating the RHS. So we get half into AE into DN is equal to half into AD into EM. Using these sets of equations, we can find a relation between the side AD and AE. Let us do that. Half and half would get cancelled. So AE by AD would be EM by DN.
Good morning everyone, this is from grade 10 and I am a student of GD Goenka Public School. And today I am here to explain you the topic internal angle bisector theorem. So let's start with it. In the question we would already have been given that there is a triangle ABC with OB being the midpoint of angle B and OC being the midpoint of angle C, which makes angle ABO and angle OBC equal. Also, angle ACO and angle OCB equal. These are the things we have been given. Here we have to prove that the angle BOC, this angle BOC is equal to 90 degree minus angle A by 2. This is the angle we have to prove. This is the theorem we have to prove. Let's start with it. First we see in triangle ABC, in the smaller triangle BC, first in triangle BOC, angle OBC plus angle BCO plus angle COB. It makes 180 degree. Why? We have learned, we are learning since grade 5 angle sum property. Angle OBC, we have been given that angle ABO is equal to angle OBC, which makes angle OBC equal to angle B by 2. It is equal to angle B by 2 plus angle BCO. We have been given that it is equal to half of angle C. Angle C by 2 plus angle COB equal to 180 degree. Here, from where we want to get the value of angle B by 2 plus angle C by 2. If we do so, we get angle B by 2 plus angle C by 2 is equal to 180 degree minus angle COB. This is the first equation here. Moving on to the bigger triangle, triangle ABC. In triangle ABC, angle BAC plus angle ABC plus angle ACB is equal to 180 degree, again due to the theorem angle sum property. If we divide the LHS and the RHS by 2, there won't be any difference. So we have divided angle BAC plus angle ABC plus angle ACB. All of them by 2. If we divide in the LHS, we will also have to divide in the RHS. So we get 180 degree by 2.
Good morning everyone. This is Avigan Sharma of GD Goenka Public School. Standing over here to discuss a theorem that tangents drawn from a same external point are always equal. So let's start. So in this figure, you can see there are two tangents named AP and BP, and thus there is a circle with center O. So in in this theorem we have to prove that tangents drawn from a same external point are always equal. So first we have to do a construction that we have to join A to O and O to B and O to B also. By doing this construction, we found that there are two triangles AOP and BOP. So in triangle AOP and triangle BOP, we can see that the line OP is common in both the triangles. So line OP is equal to OP by the criteria of common. And you can see, you know the property that tangents are always perpendicular to the radius of the circle. So the angle OBP is also 90 degree and triangle OAP is also 90 degree. So angle OAP is equal to angle OBP. And as the radius of a circle is always equal, so the line OB is equal to OA. So triangle AOP is congruent to triangle BOP by the criteria of RHS. So by simplicity we can write that line AP is equal to line BP. So as we have proved that the line AP and line BP are the tangents and they both are equal, so by this theorem we know that tangents drawn from a same external point are always equal. Thank you.